Hello friends, welcome to Tech Study Cell. In this video, we'll make a very simple Lora project to control our appliance and also monitor the feedback from a distance up to 5 to 10 km away without using any Wi-Fi and Bluetooth signal. Here you can see I have made a complete circuit without using any PCB, and you can use any other microcontroller. During the video, I have shared the complete circuit source code, so after watching the video you can easily make this project. But before going to the details, let me show you how this project works. Here you can see I have connected this AC lamp with a relay module, but you can also use a 30 ampere relay to connect a pump. First let me turn on the supply for the receiving end. We have to wait till the LED turns off. Now let me turn on the supply for the transmitting end. First it will request the current status of the relay from the receiving end, and after receiving it, it will show on the OLED. Currently the lamp is off, so it is showing relay off. Now to turn it on, I have to press this push button. The lamp turns on and I can monitor the feedback relay on. Now to turn it off, again I have to press the push button and the lamp turns off, and we also receive the feedback relay off. And I can also control this lamp from this push button in the receiving end. Let me turn it on, and we can also see the feedback relay on. Now let me turn it off. Again we have received the feedback relay off. So you can control this lamp either from the transmitting end or from the receiving end, and in both cases we will receive the feedback. Now sometime it may happen you do not receive the feedback from the receiving end. That time you will see this checking text on the OLED. That time you can press this status button to request the feedback again from the receiving end, and once the feedback received, you can monitor it on the OLED. Currently the lamp is on. Let me turn off the complete supply. The lamp turns off. If I turn on the supply again, after configuration the lamp automatically turns on. So it can also remember the previous states in the EEPROM memory. So this is a very useful project. You can easily make it after watching the video. Although I have not used any PCB for this project, but I will always recommend you to use a PCB for any electronics project, and you can easily design professional PCBs using the Altium PCB Designer software. Now Altium came up with an amazing product called Altium 365. Altium 365 is an electronic product design platform that unites PCB design, MCAD, data management and teamwork. So with Altium 365, you can not only design PCBs, but you can also share your projects to your teammates for review. The mechanical team can also access the PCB files, so they can parallelly work on the mechanical product package based on your PCB design. And there is no chance of losing design data with the automatic backup and centralized cloud storage. It also helps you to manage your components and get real-time supply chain data for all the components. It also allows multiple people to work on a single project, and finally you can send your product to manufacturing with a single click. Altium 365 automates all of these tasks for you so that you can focus on making something creative and useful. And now you can download the free trial version of the Altium PCB Designer software from the video description. In the transmitter circuit, I have used Arduino Nano, but you can use any other microcontroller. And here I have used RYLR896 Lora module. Again, you can use any other Lora module. For the serial communication with the Lora module, I have used this voltage divider to drop down 5 volt logic level to 3.3 volt. And with this push button, we can control the relay through Lora. And to check the status, we can use this push button. For the receiving end circuit, I have used Arduino Uno. Again, you can use any other microcontroller and a Lora module. And here again, I have used the voltage divider to drop down 5 volt logic level to 3.3 volt. With this push button, we can control this relay manually. And instead of the pump, you can connect any other appliances. So this is the AC circuit, and here we have to give the 5 volt DC supply. And here I have used active low relay module. These are the source codes for this project. For the transmitting end, you have to upload this code. Here you can see TX is written, and for the receiving end you have to use this code. Now you can download both the code from our website iotcircuithub.com. just visit the article. You can find a link in the description. Then you can download the code from this button. After downloading, first I will program the Arduino Nano. So let me open the code for the transmitting end. For this project, first you have to install this library for the OLED. Then here you have to enter the details to configure the Lora module. If you are using same Lora module RYLR896, then you just have to change the Lora band as per your country. I live in India, so I have selected the band 865 MHz. So you can just Google it, what are the Lora band available in your country, accordingly set the band here. Then for the network ID, I have selected 5. After that, for the transmitting end LoRa address, I have selected 1, and for the receiving end LoRa address, I have selected 2. The network ID must be same for both the transmitting end and the receiving end. And if you use any other LoRa module, then you have to set this parameter accordingly. Now let me go to void setup. In the void setup, first we are defining the baud rate, then we are configuring the display unit. After that, we are configuring the Lora module using AT command with the predefined value. After configuring the Lora module, we are requesting feedback from the receiving end. Then in the void loop, we are calling these two functions, manual control and get feedback. First, let me go to manual control. In this function, if you press the on off push button, then it will come to this block. Then we are checking what is the current pin status. If it is 0, then we are sending this AT command to receiving end. So here you can see we are sending A1 to turn on the relay if the current pin status is 0. Then this is the receiving end Lora address, and as we are sending 2 character, so I have written 2 here. And if the pin status is 1, then we are sending A0 to receiving end to turn off the relay. And if you press the status push button, then we are just requesting feedback from the receiving end. So whenever receiving end receive FS, it will send the current status of the relay to transmitting end. Now with the get feedback function, we are checking if there is any data available in the serial terminal. So whenever we receive any feedback from the receiving end, first we are comparing the data, and if the data is valid, we are displaying the data in the OLED. So the code is very simple. Now let me go to tools, select the board Arduino Nano and select the proper port, then hit the upload button to upload the code. Now we will open the code for the receiving end circuit. So this is the code for the receiving end. You will find relay is written. So let me open this code. Now for this code, you have to install the ACE button library. Now again, here you can see I have entered the value to configure the Lora module, and as I said, the network ID must be same for the receiving end and the transmitting end. Now again, I have used D2 and D3 for the serial communication with the Lora module. Now let me go to void setup. So again, first I have defined the baud rate, and here you can see with these AT commands we are configuring the Lora module at receiving end. Now in the void loop, we are calling these two functions. Now first let me go to Lora control. In the Lora control, first we are checking if any data available in the serial terminal. So if we receive A1 from the transmitting end, then we are turning on the relay. As we are using active low relay module, so low signal will turn on the relay. Then we are sending feedback to transmitting end, and if you receive A0, then we are turning off the relay. And if you receive FS, then we are just sending the feedback to transmitting end. The code is very simple. Let me upload this code to Arduino Uno. So let me select the Arduino Uno, then I will select the port, then hit the upload button. Now let me turn on the supply. Now here we have to wait till the LEDs are off, and after configuration you can see relay off is showing on the OLED as the lamp is off. Now if I press this push button, the lamp should turn on, and we can monitor the real-time feedback relay on the OLED. Now let me turn it off. You can see the lamp turns off, and again we can monitor the relay off on the OLED. If you find this project helpful, please hit the like button and share it with your friends. Don't forget to subscribe for more such videos. Thank you for watching. Have a great day.